Hello everyone, my name is Shalini, student of SVCE. In this video, we will be learning about creation of class and objects and method overloading and method overriding. Here we have the contents. Introduction to classes and objects in Java. What is a class? Defining a class in Java. Example of class definition. What is an object? Creating an object from a class. Example of creating an object. Accessing class members through object. Example of accessing class members. Introduction to method overloading and method overriding. What is method overloading? Example of method overloading. Benefits of method overloading. What is method overriding? Example of method overriding. Difference between method overloading and method overriding. When to use method overloading and method overriding. Best practices for using method overloading and method overriding. Key takeaways. Starting with the introduction to class and object. Java is an object-oriented programming language which uses class and object as fundamental building blocks for creating applications. What is a class? Blueprint for objects. A class is a blueprint for creating objects. It defines the properties and behaviors that objects can exhibit. Encapsulation. It encapsulates data for the object and provides methods to manipulate that data. Code reusability. Classes offer code reusability by allowing multiple objects to be created based on the same blueprint. Defining a class in Java. In Java, a class is defined using the class keyword followed by the class name and its body enclosed with curly braces. As seen here, first the class keyword is used followed by the class name, which is my class, and the body is enclosed within the curly braces. Next, we have an example of a class definition. An example of class definition for a class car with attributes like color and speed and a method to increase the car's speed. The increase the speed is the method which is used to increase the car's speed, and the color speed are the attributes of the class car. What is an object? Real world entity. An object is a real world entity with a specific identity, state, and behaviors represented in a program. Instance of a class. When a class is defined, objects can be instantiated from it, each with its own unique state and behavior. Creating an object from a class. Instantiate. First, we have to use the new keyword to instantiate an object from a class, and then initialize, assign the object to a reference variable and call the class constructor to initialize it. Next, we have an example of creating an object. An example of creating an object, my car, from the previously defined car class and accessing its attributes and methods are given here. First, we have to use the class name, then followed by the object name. Here, my car is the object name, and then equals to, and the new keyword, and again the class name. Accessing class members through objects. Dot notation. Use the dot notation to access the attributes and methods of an object. Visibility modifiers. Ensure that the class members have appropriate visibility modifiers for access control. Here we have an example of accessing class members. First, we have to use the object name followed by dot, which is dot operator, and then followed by instances. Using the dot operator and object, class object, we access the class members. An example demonstrating the access of class members such as color and speed through the object myCar is given here, where myCar is the object and then the color is the instance and increase speed is the method. By the way, we have introduction to method overloading and method overriding. Method overloading and method overriding are two important concepts in object-oriented programming. They allow developers to create more flexible and organized code. What is method overloading? Definition. Method overloading is the ability to define multiple methods with the same name but with different parameters. Usage. It is used to enhance the readability of the program. It helps programmers to write more readable and reliable code. Example, when a class has multiple methods having the same name but in different parameters, it is known as method overloading. We have an example of method overloading in Java. Here we have a class which is overload demo, having a method test with no parameters, followed by another method test with the same name as the prior method, but having one parameter, followed by another method having two parameters, and followed by another method having one parameter, and a return statement here that is a into a. And we have a class overload here, which is having the main function, and object is created for the method overload demo, that is OB, and then the methods are called here using the object OB. During the first call of the method test, no parameters are passed, hence the first method will be called. During the second call, the second method will be called, and during the third call, the third method will be called, and during the next call, the fourth method will be called, and the result will also be printed, which is a into a. This program generates the following output: no parameters, then it prints 10, then it prints the value of a and b, 10 and 20, then it prints the value of double a, which is 123.25, then the result of ob dot test, which is 123.25 into 123.25, which results in 15,190.5625. Next, we have the benefits of method overloading. Code reusability. It allows the same method name to be used for different operations, improving code reusability. Easier maintenance. It makes the code more readable and easier to maintain, reducing complexity. What is method overriding? Definition: method overriding allows a subclass to provide a specific implementation of a method that is already provided by its parent class. Usage: it is used to implement runtime polymorphism. It allows a child class to provide a specific implementation of a method that is already provided by its parent class. We have an example of method overriding here. We have a class A having variables I and j, and a constructor as the same name of the class A. A constructor A having two parameters A and B, where I is assigned to A and j is assigned to B. And we have a method show which displays the value of I and j. And we have another class B which extends A. And in the class B, we have a variable K and a constructor B with three parameters A, B, and C. And then the K is assigned to C. We have another method show in the class B, which prints the value of K. Here the method show, which is present in the class B, overrides the method show present in the class A. We have a class override with main function and a object for class B, that is sub OB, and then the show method is called using the object sub OB. Since the method show present in the class B overrides the method show present in the class A, as a result, it prints only the value of K. We have the difference between method overloading and method overriding. Method overloading, method overriding. In method overloading, it occurs in the same class. In method overriding, it occurs in parent and child class. Here there are different parameters, whereas in method overriding, it has same parameters. Here no overriding of superclass methods. Here overriding of superclass methods takes place. When to use method overloading and method overriding? Method overloading: to create multiple methods with the same name but different parameters to achieve flexibility. Method overriding: to implement runtime polymorphism to achieve flexibility and dynamic behavior. Best practices for using method overloading and method overriding. Method overloading: use descriptive parameter names for clearer code. Method overriding: avoid altering the original behavior significantly for maintainability. Summarizing the prior slides, summing up, method overloading and method overriding are valuable tools for creating more flexible and maintainable code in object-oriented programming language like Java. Benefits: These concepts enable developers to achieve code reusability, maintainability, and flexibility, fostering better software development practices. Objects as abstractions. Objects in Java help to create abstractions of real world entities, making programming more intuitive and manageable. Class object relationship. Understanding classes and objects is fundamental to object oriented programming and lays the groundwork for creating robust and scalable applications. Thank you.